Good everyone, my name is Graphics. Today we'll be looking at a course called Fluid Mechanics. We'll be looking at the basic terminologies that we use in this particular course. Now, first of all, what is fluid mechanics? Fluid mechanics can be defined as the branch of science that deals with the behavior of fluid at rest and as well as in motion. Now, if you look at the word fluid, in our junior level, we discussed about matter, and we said that matter is matter is the quantity of mass, or we say matter is anything that has mass and can occupy space. Now we have three states of matter: solid, liquid, and gas. Right? Solid, liquid, and gas. Now you look at the solid, we know they are closely packed, and liquid and gas, their molecules are loosely packed, so they can easily flow. So because of that reason, we call both gas and liquid a fluid because they can flow. So now fluid mechanics can be divided into three. We have the statics, we have the dynamics, and we have the kinematic. Now, if you look at the static fluid is divided into two. When you say the word static, it means something that cannot move, right? So static is the branch of fluid mechanics that deals with fluid, incompressible fluid at rest. Now I'll use the word fluid because your static can be either liquid or gas. So when you talk about that of liquid, you call it hydrostatic. Means that this is incompressible liquid at rest. You call it hydrostatic. Now the other one we call aerostatic. Means compressible gas at rest. Right? It's a branch of fluid mechanics that deals with what? Compressible gases at rest. Now we'll go to the other aspect, which is called the kinematic. The kinematic deals with there's an aspect of fluid mechanics that deals with the forces. When I talk about the forces, I mean the energy that causes the motion. When I mean motion, I mean the speed, the acceleration, and so on and so forth, without considering the force that causes it. Right? Now we move further and we'll be talking about what is called the dynamic. The dynamic deals with the relationship between the fluid at rest, or deal with the relationship between the fluid, the energy that causes the motion of the fluid, and the fluid itself. Right? So we'll move further. We'll be talking about the properties of fluid. The properties of what? Of fluid mechanics. Now we are looking at the properties of a fluid. We say the property of the fluid is the observable characteristics of the fluid. And we have different types of property, which I will name now. The first one, we talk about the mass density. The second one, we talk about the weight density. Now, the mass density is also known as the specific mass, while the weight density is also known as the specific weight. Number three, we're talking about the specific volume. Number four, we are talking about the specific gravity. We have also the viscosity, we have the capillarity, we have the adhesion, we have the cohesion, we have the compressibility, we have surface tension, and so on and so forth. Now I will start with the mass density, which is also called the specific mass. It is represented using the small letter m, and it is defined as the ratio of the mass of the fluid to its volume, right? Now it is measured in kilogram per meter cube. Mathematically, we say that the density, this is the symbol given as rho, is given as the mass over volume. That is the first properties. Now the second one is given as the weight density or the specific weight. Now you can use the symbol as in terms of gamma to represent it, or you can use your small letter w in form of omega to represent the specific weight, and it is defined as the ratio of the weight of the fluid to its volume. It is measured in Newton per meter cube. Mathematically, we say the specific weight or the weight density is given as the weight over what? The volume, both in capital letter. Now, if you move further, the weight we know is given as what? The mass times gravity. Now, if you divide this over volume, you discover that the mass over volume can also be given as what? The density. Now, we now say that the specific weight or the weight density is given as what? The density times what? Times the gravity. Right? So, that is the second one. Now we say the specific volume is given us the volume over the mass. Now the bigger volume over the small mass, and is represented in, like I said, in meter cube per kilogram. Now recall in mathematics, if you have a fraction saying the numerator over the denominator, now if I want to inverse it, I will introduce a 1 on it. So we say that 1 over the volume over the mass, same as saying the mass over the volume. Now we know that my mass over volume is given as density. So we say that what? The specific volume is given as what? 1 over density. Now the other one, we're talking about the fourth one, so giving us as our specific gravity. Specific gravity is the ratio of the density of a fluid to the density of a standard fluid. If you know what the density of a fluid in terms of water, in terms of liquid, we talk about water, and in terms of gas, we talk about air. Mathematically, we say that the density of a liquid over what? The density of a standard liquid, which is given as what? Water. It has no units. Now the fifth one we're talking about will be the viscosity. Now we know the viscosity, which we'll discuss in our later video, but before then, let's go into a problem where we can make use of these terminologies, these parameters, these properties that were just analyzed here. So problem 1, it says, problem 1, it says calculate the density, specific weight, and weight of 1 liter of petrol of specific gravity 0.7. Now, in this question, the first thing you have to do is to write out your parameters. Now, the parameter given in this question, it says we have the liter, which is the volume. The volume is given as what? 1 liter. Now, to convert 1 liter into meter cube, what we are going to do is that we are going to divide by 1000. That means if I have 2 liter, I'll divide 2 by 1000. So in dividing 1 by 1000, we are going to have 0.001 meter cube. So it means 1 liter is equal to what? 1 is equal to what? 10 raised to power minus 3 meter cube. So that is 1 liter. So now the specific gravity given is giving us, the symbol for specific gravity is x, or you say s dot g, which is giving us 0.7. Now the first thing we have to calculate is the density. Now if you recall that the density can be calculated from the formula of specific gravity, which is giving us specific gravity S is giving us the density of a liquid divided by the density of a standard liquid, which is what? Water. Now we know very well that the specific gravity S is 0.7 and the density of the liquid is what we're calculating for, all over the density of water, which is giving us what? 1000, giving us what? 1000 kilogram per meter cube. Now if you make the density of the liquid the the formula, we are going to be having the specific gravity 0.7 multiplied by 1000, and that is going to give us 700 kilogram per meter cube. So that is the density of the liquid. Now what is the liquid we're talking about? We're talking about the petrol. Now the next one is the specific weight. We know from our formula that for specific weight is giving us the density times gravity. Now what is the density here? Density is giving us 700. And what is the gravity of the liquid? Is 9.81 Newton per meter square. Now when you multiply both of them, it's going to give me 6867 Newton per meter square, meter cube. Now the next one what to calculate is the weight. We know that the specific weight is giving us the weight over the volume. Now the specific weight will now be the weight over the volume given is 0.001, and the weight calculated for, specific weight calculated for earlier is 6867. Now if you input your data, you say that the 687, which is specific weight, is equals to what? The weight W over what? 0.001, which is the what? The volume. Now if you make your weight instead of the formula, the weight W will now be equals to 6867 times 0.001. That will give us 6.867 Newton, and that is our answer. Now the second problem we have here, we are told that calculate the specific weight, density, specific gravity, of 1 liter of a liquid which weighs 7 Newton. Now, like I said earlier, the first thing you do is for you to write out your parameters. Now, the data given here is the weight is given to be 7 Newton and the volume is given to be 1 liter. Now, converting 1 liter into meter cube, it will be 1 divided by what? 1000, and that will give us 0.001 meter cube. Now, question 1, we're told to calculate for the specific weight. We know that the specific weight is the weight over the volume, and the weight given here is given as 7 Newton over the volume, which is what? 0.001. And when you do your mathematics here, calculate it, it will give us 7,000 Newton per meter cube. Now, the next one, number 2, so to calculate the density. We know that the specific weight is given as what? The density times what? The gravity. Now, if you make the density subject of the formula, we'll say that the specific weight over gravity will give us the specific weight over gravity. Now, what is the specific weight? That is 7,000 divided by gravity, which is 9.81. This will give us 713.5 kilogram per meter cube. Now, the third one, we are told to calculate specific gravity. We know that specific gravity is the density of the liquid over the density of a standard liquid, which is water. Now, the density of the liquid calculated in the previous question here is given as 713.5 divided by the density of water, which is 1000 kilogram per meter cube. And when you do your calculation here, it will give us 0.7135, and that is our answer. So, if you have found this video helpful, please don't forget to click on the subscribe button. Thanks for watching.